Geometry Middle School. Reviewing middle school geometry. We are going to review geometry. Typically, you learn in the middle school these basic of geometry even before you go to high school levels, which talk about Euclidean geometry. Okay, so before the precise definition, geometry typically start with elementary school and the middle school. It's all about visual perception, and mathematically speaking, it's not rigorous mathematics. It's based on the perception, but there are a lot of theorems developed even before precise definition. So that's what we learn about here. The first one you learn is Pythagorean theorem. Pythagorean theorem is a relationship of the side, the lengths of the side for the right triangle. The lengths A and B are perpendicular. Hypotenuse length C is C square equals A square plus B square. Okay, and according to this, we can calculate some of them. Like when it's 1 and 2, it's going to be square root. Hypotenuse length is square root of 2. 30 degree and 60 degree go 1:2 ratio and the square root of 3. And this is a very basic right triangle. You need to memorize this, because the most of question, SAT, whatever, it's assumed that you remember this one, the basic triangles, the figures. Okay, that's that. Now, how do you prove Pythagorean theorem? There are many different ways. I think it's the easiest one you can look at is, if you want to really prove, is this one. You have the length C, rectangle, not rectangle, it's a square, and this square have a triangle ABC on the side, and second triangle, third triangle, fourth triangle. And now, since this and this angle summation is 180 degrees, so it's guaranteed to be, it's a straight line here. Same way, straight line, straight line, straight line. So you create the new square. The length is A plus B. So large box has an area of A plus B times A plus B, A square plus 2AB plus B square. Small triangle have the total area of 4 times your 4 triangle, 1/2 times AB is 2AB. Therefore, the area of the box inside will be C square equals A square plus 2AB plus B square minus 2AB. So C square equals A squared B square. Okay, so this typing is confusing. Actually, it's square. Okay, so very simple proof of Pythagorean theorem. Now, another important things you learn is a characteristic of triangle. Congruent triangle. Congruent. What is congruent? It's identical triangle. How can you say triangle A is equivalent to B, identical? Well, one way to say is, if the length AB is same as A prime B prime, and AC is same as A prime C prime, and the BC is same as B prime C prime. It must be identical, because when you give the lengths of AB, BC, CA, it's defined triangle uniquely. There's no way you can have two different triangles with three lengths given. Okay? Or another way is AV and A prime B prime is same, and angle AB on the both sides of the side AB are same. Then that's going to be equivalent triangle. The another way is AV and A prime B prime, and AC, this one, and A prime C prime, and angle between them. So AB and C. If this lengths, two lengths are given and angle between is given, then it's uniquely defined the triangle. There's no other way to define. Okay. So there is a one triangle congruent condition that is not true when you give the this length and this length and not angle between them, but instead one side of angle. Does it uniquely define the triangle? It's not, because this length can be either this way or this way, so it can define the two different triangles. So that cannot be the congruent condition. That means you give two lengths and define the angle here. Okay, so this is not congruent condition. This example illustrates that it's not a congruent condition. If B is 90 degrees, then condition above determines only one triangle. So when triangle, the angle here is 90 degrees, then it's determined only single triangle. So you give this length and this length and 90 degree. So this length can be either this or this, right? And they are identical triangle. Its orientation is different. Now orientation is like a flipping. The important things about congruency is this triangle and this triangle is considered identical. Okay, they are identical when you flip it or rotate it. Okay, now similar triangle. Similar triangle is different. Similar triangle is they look similar, but the size is different. So it's not congruent, but similar. Condition for similar is this angle is same and this angle is same, but AC and A prime C prime can be different. So it's created two different size triangle, but they look very similar. Now again, it's similar even you flip it. Like, okay, this triangle and this triangle can be similar. Okay, you flip it. And now, similar condition, AC A prime C prime, this ratio this ratio, this and this ratio is same as BC and B prime C prime. Okay, and one angle is same, so that's makes similar too. The other way around, the ACBC, this ratio is same as A prime C prime and C prime B prime, same, and angle is the same. So basically you have one angle and this ratio, if ratio is same, you divide this into the same ratio, that's going to be similar triangle. Okay, then another condition is AB over A prime B prime, AB over A prime B prime. So all the three side ratio is same ratio. Say the triangle shrunk by the ratio, say P, okay, then every side the lengths become shrunken by ratio P, then that's similar. So similar condition, a little bit more complicated, but you get used to it if you do some exercise. So here's the exercise. Pythagorean theorem. Find A square, B square, C square, and D square, E square, F square. Okay. Sine, cosine, and tangent. Now, you learned this in the high school trigonometric function, but before that, geometry, typically you learn at least the definition of sine and cosine within the limitation of geometry. What it means is geometry define those functions only for something you can draw, like triangle and angle P. So definition is cosine, this is C, sine, right? So the cosine is AC, C over A, sine is C over B. That's how you remember cosine and sine. Okay, and tangent, the way you remember is tangent, triangle, T, right? So it's going to be B over A. Okay, so this is the practice to figure out what is the tangent 60, sine 60, cos 60, and the 45. If you know this triangle's ratio, you can answer this. Okay, next question is find BC when angle is kind of strange angle, which you cannot use your memory, right? So what we do is draw line from A to segment BC orthogonally here. Okay, and 65, you can find out this length and this length, right? And you know this angle because 180 minus 90 minus 65 is going to be this angle. So that means you know this angle, the remaining 40 minus this angle, right? And once you know this, then you can calculate this and this. So you know this plus this will give a BC. And you need a calculator for this. you have to practice how to use calculator to calculate the arbitrary angle. The SAT2, they require that. So practice this question. For a regular hexagon, prove triangle AOF. AOF here is a equilateral triangle. This triangle is equilateral. Also prove that all diagonal lines have the same length. This length same. Well, it's easy, right? Once this is equilateral to this, all of them equilateral. By definition, the regular hexagon means this length is same. This is 360 degree divided by, so it's a 60 degree. So this is 60 degree for each, right? And 60 degree. The equilateral is this length and this length and this length is same. Okay, so 60 degree, if you divide into 2, 90 degree, then this is gonna be 30. That means it's 60. So you know the triangle 30 and 60 means this length A, this 2A, and the other side A. So you can tell this length and this length is same. Okay, so this is equilateral triangle. Equilateral triangle is all side same, right? The once they are equilateral triangle with the same lengths, then it's all congruent. That's the proof. When AB equals 5 and BC is 6, this is 5, BC is 6, find the AC. Again, what you do is you drop the perpendicular line. From this 6 and angle, you can calculate this and this. So remaining this is 5 minus, if this is alpha, alpha, right? And you know this and this, and this is right triangle. So using Pythagorean theorem, you can calculate AC. Okay. When AB is 5, BC is 7, AC is 4, find the height of CD, this one, height, H. But we don't know this one. So H AC square minus H is AD square, right? And BC square minus H square is DB square, Pythagorean theorem, right? And DB equals AB minus AD, right? So you combine this all together, solve for H, solve for H, you get H. Okay, use a paper and pencil, practice this. You can stop the video while you're practicing. When AB is 5, AB is 5, and find the length of AC. What is the length of AC? Again, you drop the perpendicular line, okay, and assume this is H, and this is gonna be 5 square plus h square square root. So once you know the h, you know this length. What is the h? It's not 5, I'm sorry. We need to know this too, because AB is 5. We don't know this. And we don't know this. Okay, but this is 60, right? So it's a 30. So we know the ratio. This, say this is x, then this is x, right? So 5 plus x square, Pythagorean theorem, plus x square is going to be AC. So we have to make another equation to find out x, right? This is 30. So you know dca square root of x is going to be 5 plus x, right? Because this length divided by square root of 3 is going to be this. So you got the two equation, and you can solve x here and plug into the x here. Okay, I hope you're following. Now find the midpoint of the line segment using only a compass and a ruler. How do you do that? Okay, you have a segment AB and you draw the circle using compass. The radius is arbitrary but bigger than half of the AB. So two circles intersect here. Since you draw the triangle here, this is R, 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 and a common. So this is a congruent. That means this length is the same. So this is a midpoint. You get that? Okay, you can prove that. Find a way to draw a circle that fits outside of an arbitrary triangle. Assume you only have a compass. Prove why the method works. Okay, so find a way to draw a circle. Let's go step by step. Find the midpoint of BC by drawing two circles, and find the midpoint of AB, drawing a two circle, and this line bisect this line, and this going to be equal distance from A, B, C, because it's why is that? Because this is same and this is same, because we prove this same way. So when you got the same distance from O to A and B and C, you can draw a single circle. Okay, actually like that. Okay, draw a square box from a line segment given. So what you do is, this is a segment, and you draw the circle here and extend the line. So extend this. Now we take a B as a midpoint, draw the line. So that's the perpendicular line, and this is gonna be same as this, right? Okay, so from here we draw another the same radius from here and here. This gonna be square. Okay, draw a rectangular octagon within a circle. Well, we draw when we know the center point, we draw the line AB and find the midpoint perpendicular line DC. And now we divide the angle between BC, CA, AD, DB, and draw the line again. Okay, so from here to here, it's going to be octagon. Okay, so the almost endless number of geometry questions for middle school. Actually, you look at any exercise book, it's you solve them all during a summer holiday or whatever, when you have a time, then you will be very skillful for answering the geometry question. And that is the best part of the geometry. You have so many different questions you can challenge, the challenge after challenge, and that's a way you polish up your math skill, and you start enjoying solving geometry question. Okay, I hope you enjoy listening this video, and I'll see you in the next video.